So yeah, just reiterating the agenda. So yeah, we've got Charles starting off, um, talking about Apache Beam DaskRunner. Then Matt's going to talk a little bit about Dask array expressions. And then Sarah's going to talk about her work recently on the 1 billion road challenge with Dask. So yeah, and then each person, we've got three speakers. Feel free to, normally we keep this 5 to 10 minutes. We've only got three speakers. So if folks want to go a little over that, feel free to. Should still have time for discussion. So thanks everyone. And yeah, Charles, the floor is yours.
Awesome. Thanks, James. Let's share this window. So, classic demo fashion. I thought this ran. I had the environment and everything. So I'm using the pre-run version. It's a little bit less dramatic, but it did work. I didn't like edit the uh, metadata of this file manually. Um, I'm just gonna kind of like run through very quickly what this looks like, and we're kind of like save the kind of conceptual discussion for the end. So we're just like gonna jump right in. But I guess I'll say ahead of time, there was a previous Dask Demo Day topic on the same subject, the Dask Runner for Apache Beam, and that was presented by Alex Morose, who was formerly a Google Research software engineer. He started this project following some collaboration that we have been doing together on the Pangeo Forge project, which I'll also mention in a second. But it was very early, and so I've kind of taken that over and kind of giving like a kind of state of the runner, state of the Dask runner update here. But I'll just jump right into kind of what it looks like, just to orient everyone first. So at some point in history, I did start a Dask client, and this was what we used for the example. So there was a local client started, a local Dask client. The Dask runner in Apache Beam, as it's currently implemented, is a uses the Dask bag interface. So I developed this notebook based on some of the like tutorial examples on Dask bag. So anyone who's seen the tutorial examples on Dask bag might be familiar with this kind of people data space of some JSON temporary directory. And this is kind of just a little view of what that looks like. We have some JSON lines with some theoretical, some imaginary people with some ages and occupations and credit card numbers and things. So this is just, recreating something of what the Dask bag kind of chained computations tutorial shows us. And it's a little bit edited to just show something that can also be replicated in the Dask runner today with Apache Beam. But essentially you can, probably many are familiar, you can create a Dask bag by reading some text files and load those into JSON objects or Python dictionaries, and then filter them and map them in different ways. And from a large collection of things, we ended up with this subset of filtered three different people whose first names start with A, last names start with B, within a certain age range, etc., and whose careers start with or occupations start with C. So I just did this just so that you can see what this looks like in Beam. Um, so it's quite similar. It's just another kind of a chained operation that's the operations that are layered on top. You are also doing something quite similar, loading from a directory of taking the glob or list of directory, filtering in ways that are, the syntax is in some ways quite similar. In Beam, the operations are chained with pipes in kind of this Unix style instead of dots. But basically, you can do something similar to this. Actually, the Dash Runner in Beam can't be run interactively in an IPython session, which is why I have this in text. Um, and again, at some point in history, when I worked on this previously, I was able to run this as a Python script and get the same result that we had before. And for some reason, that wasn't working just now when I was loading this notebook. But something that I wanted to highlight was that essentially the deployment of this job is done typically from like with a command line uh, interface like this. And you can pass arguments, including the address of a Dask client. So the scheduler address. When I ran this previously, I passed that as right there, and essentially this same computation is compiled, in the back end into a Dask bag graph and then run on the same cluster, and we got the same result. I will say that there's definitely a lot of room. It's If you look at like the kind of colors on the Dask graph, it's definitely compiled in a way that's not as efficient as Dask natively does. Not surprisingly. So like you'll see different reds on the graph and intercommunication issues that are definitely not as efficient as Dask is natively doing. There's possibly some room to improve that. Um, I'll address this note that I gave to myself in the discussion. So, okay, so why would we like twist ourselves into knots to do this awkward thing? I just said like Dask Bag can do this better than Beam can try to replicate it and more efficiently. So Apache Beam is a kind of generic framework for distributed, quote, data flow style data processing, and it has a large built-in community. It's a lot of it is driven by its kind of largest corporate sponsor, Google, but Google is a pretty big company, and there's a lot of internal use of Beam at Google. And maybe Jacob can comment, but I've understood that maybe at least some former Googlers at NVIDIA also kind of have carried that interest over and wanting to use Beam a bit internally at NVIDIA, and that may be true at other companies as well. But in my experience, which has now been a couple of years with Apache Beam, so Apache Beam, one of its selling points is like it deploys to compile to different types of backends, and it can run on different types of Kubernetes clusters and Apache Flink and Spark, etc. Google has a managed service called Dataflow, which is definitely the easiest way to deploy it like into the cloud. But it has very, very bad like deployment stories for local deployment, a almost non-existent story for HPC, and AWS is something that like some pretty smart people I've been working with for like over a year are still trying to figure out how to get it to run on AWS using Apache Flink, which is like the recommended cluster. But all these Apache, Kubernetes based deployment targets are like really hard if you're not super good at Kubernetes and really familiar with them and maybe have a whole DevOps team. And I think Dask has a really amazing role to play for like the Beam community and Beam enthusiasts who maybe are working in smaller, more agile teams, maybe coming from the scientific background or some other background where they have exposure to Dask, they already have Dask clusters, or they don't have Dask clusters, but they can read the Dask docs, and it's so much easier to deploy Dask than it is Flink or any of these other recommended things for AWS. Not to mention it opens up all this potential for HPC and local deployment, etc. So I think Dask has an amazing role to play. The Pangeo Forge project, I'll link this to you guys in a second. This notebook, you can link over to it, is one motivator for that. Xarray Beam is a Google project that, could be another example. Uh, Ignore this last thing. That was oopsies. That was incorrect. So and I'll wrap up. I know I kind of over the 5 minutes, but just really briefly, what works today? You can compile Beam pipelines today and run against various runners, including Dask. And in Dask, there's element-wise operations that are strictly element-wise with no cross-process communication, like maps, flat maps, filters, etc. Anything that's like fanning out and out and out, or just or completely parallel in the graph works really well. And group bys work with string and numeric key types, but this actually gets at this thing that I know Matt knows that I've been kind of trying to pick away at it. Just a little thing with kind of key serialization in Dask Bag, but some limited group bys work. Next step is I'm very, very close to group by with arbitrary key types. So like what I mean by that is, yeah, maybe like a frozen data class. Like you could use a arbitrary frozen data class as a key or something like that. Folds is like I want to implement DaskBag fold. So you can do arbitrary types of folds in Apache Beam, and then any other amazing ideas that you have. So this is just a little state of the DaskRunner. Sorry, I'm a bit over the 5 minutes.
No, that's
Hi,
great.
Charles.
Thanks,
That
Charles.
was, yeah, that was
Very
great.
cool. Jacob, I know this is sort of I don't know if this was mentioned ahead of time, but like my sense is this is a sort of collaboration between you two, you've been working together. Jacob, I
But
don't know if you have anything you wanted to add on top of this.
I mean, I've been partly involved in this. Charles has driven this today, which is awesome. So thank you for doing that. I contributed a bit to Beam recently. Like was said, this is like a growingly popular thing inside NVIDIA. There's a bunch of ex-Google folk here that love it. They're trying to use it on HPC. They're not having a good time. They came to us as like, oh, the Dask people can help us. They're running a lot of HPC stuff. And then they ran into some problems with scaling that we fixed some bugs on the Dask and the Beam side and things seem happy. But there's like lots more things to do kind of to make this better. But it's a growing in popularity API inside NVIDIA for sure.
And I see James's question in the chat, and yeah, I mean, James, the answer is that's exactly the dream that I would have is like if you have a coiled clustered on AWS or some other thing, you can just give Beam the address for that scheduler, and you can and you're off and running. That's kind of where we would go with this.
Cool. Thanks. Yeah, thanks for bringing that up. Yeah, my specific question is is there any other kind of additional setup other than like, no, you just need to like have a Dask cluster on wherever really, and then like you said, add the Dask runner, pipe the Dask runner. I shouldn't, apply the Dask runner to whatever context you're in, and then yeah, pass the scheduler address. So it sounds
There's
like today. Oh,
go ahead. Sorry.
I was saying my understanding from this was like the limiting factor was more like kind of like what you're getting at, that compilation step is the limiting factor from a deployment side. Again, ignoring the Dask deployment stuff because that's hopefully easy. Um, it's just the compilation is the bottleneck here.
Correct. Yeah. So like internally, and it's not super esoteric. Like internally in Beam, by the time you're deploying to the Dask cluster, you're just, basically submitting futures in pure Dask code, like to Dask things.
Mhm.
And so by the time you get there shouldn't be any other setup than that you would have beyond what you would do for deploying Dask objects to a Dask cluster. And your view or understanding is correct. The main limitation is trying to get like kind of full parity on operations and implementing those operations in the compiler, in the graph compiler. But the deployment should just be plug and play.
Cool. Okay, that's great here.
I'm gonna
I have another
jump
question, but I want to leave space for other folks. Yeah, Matt, if you have a question.
briefly. So just like summarizing the chat, James like softly asked like, if I had a way to deploy Dask clusters on the AWS, would that be useful? And James like, yes, coiled is the best way to like run Beam on AWS right now, which is interesting. Putting my for-profit hat, like, sure, like we can deploy stuff. Like we actually like deploy Spark on coiled right now, mostly just for internal benchmarks, but it's actually like not, we're like pretty good at deploying things now. Like if there
Precept two.
exists, I don't know, a couple of customers out there or a few customers who would actually use this, like I think the effort here is pretty low. Like when it's at those customers, we'll talk to them, make them happy, then like, you know, launch a Beam on AWS thing and market that. Maybe Jacob or Charles or someone, if you've got people in mind that would use this today, let's chat. It'd be fun. And I think pretty easy.
For sure. Those people could also be you too, but if there's other people too, that'd be great. Um, that was actually my question was, but a softer version of that, which was, what other users are interested in this? I'm curious to find out more. So great.
I'll leave time for, the other presenters, but I'll say briefly, I think I am the biggest user that I'm aware of, but I don't necessarily know how to translate that into like, a purchase order or something today is the biggest user that we have for Pangeo Forge, which is an open source earth science ETL tool. For this kind of thing is basically any federal customer that wants to use our code that's Beam, but is locked into AWS contracts. So NASA, USGS, like we have gotten good at deploying at Columbia University to GCP because we have GCP and GCP makes it easy with data flow. But NASA and USGS, as two examples, we have people interested at both of those agencies to be using Pangeo Forge, but they don't have GCP. They have like long-term AWS contracts and can't use GCP. So that, that's kind of my main direction and motivation personally.
That makes perfect sense. We should take this offline, but like you should connect us to those
Yeah.
people so we can talk to them and say like, hey, if we develop this thing, would you use it? Would you pay for it? That's the question I want to have before like investing a lot of resources into it. But it sounds like that's a very achievable conversation to have.
Cool. Okay, great. Thanks
Oh.
so much, Charles, for the presentation. Cool.
Thank you,
Moving
everyone.
on to the next person, Matt. If you want to, the floor is yours.
Yeah.
Matt's going to be talking about array expressions.
And we'll take off my for-profit hat. Sorry, setting up screen share for a second. There we go. Yeah, so Patrick is here, but like I think heading on vacation. I'll briefly say Dask data frame array expressions are making good progress. I think today they actually got like CI passing with a lot of exfils. So we're well on our way. I believe the hope is to do a release sometime like a month from now, where like Dask data frame will be ripped out and replaced with a completely new code base, which is super exciting. In the meantime, we're also thinking about arrays, doing the same thing with Dask expression, which is a system for query optimization. So the idea is it's the same Dask you know and love, but it's not going to rewrite your code in better ways to do things like improve in data frames, selecting the right columns, reordering joins, doing filters or join replacement. In arrays, there's other things we might want to do. People often screw up chunking, for example, or they should order operations a little bit differently. And we'll see some examples of that. So a little bit during the sort of holiday break, I was playing around with this, or a little bit before the holiday break, I was playing around. And so there's some basic stuff on Dask Array, which works. All like the hard problems are 80% of the hard problems are done. And the other ones are, let's see, waiting for, sometimes it takes like a second for this guy to show up. There we go. Okay. So things are set up there. Yeah, so just very briefly, I'm making a random array. So this is using Dask array, but actually from this Dask expression library. So it's not the normal Dask array you know and love. And here's like a pretty simple example of taking X, adding it to its transpose, adding 1, doing an NumPy func around it, doing some slicing, doing some reductions, and then having it all run in Daskland. So this gives you a sense for the kinds of things that work in this new reimplementation of Dask array. What's different about this versus the old Dask array is that we now have a sense for the operation that was run. So we've got a high level understanding of what's going on, creating some random data, we're transposing, we're adding it to the same random data, and we're slicing. You see the slice here. And so because we now have the operation stored as a data structure, we can manipulate that data structure and we can simplify it, we can optimize it. And so in this case, I think we pushed the slicing operation down and we sliced sort of beforehand down in here. So we're calling numpy.sign half as much because we're pushing this slice sort of earlier on in the computation. And you can see that in this tree here. These slices have been moved down the tree rather than up the tree over here. So this is showing you how thinking about this data structure or this expression can help us avoid excess work. This will probably run a bit faster. What's interesting, we'll get into like the optimizations are really interesting here. So like the slicing here of slicing every 2 on the first column, the first dimension, like works great going through element-wise operations, but when we like pass that through a transpose, we then need to like transform the slice as well. So the optimizations in Dask array get very interesting because of the multidimensional nature. But stepping back a little bit, let's just look at optimizations. So like a super simple optimization is it's like if you transpose something twice, then simplify that is the same as just not transposing at all. And this is the kinds of things that the query optimization is doing. This is a kind of a contrived example because transpose isn't that common of an operation, and it's also not that expensive. but this is showing you how sort of Dask can now rewrite your code to a smarter thing. Transposing twice, you just shouldn't have done. It's an inverse of itself. Another good example is slicing, right? So if I'm slicing here and maybe I want to, actually let's go further, right? Let's like take this slice and let's grab, the fifth element here. So we got two slices, and now we might simplify that. And so now we can choose to sort of merge those slices into a single slice. And so again, Dask does some of these optimizations already on the low-level task graph, but now we're doing it at a higher level, which actually allows us to remove all of low-level task optimization. This is actually the last remaining low-level. This sort of slice fusion was the hardest thing for us to do. And we could also imagine putting that slice down here into the random thing at some point too. We're sort of learning how to combine all these operations. I think actually the most valuable optimization that we're finding is in rechunking. So for example, here I create two arrays of different shapes. I add them together, and then I rechunk them afterwards. For example, I might rechunk because I need to, I've got everything by space and I've got to operate on time or something. Or I want to sort of, there's various reasons why you want to rechunk in these computations. And what's nice about rechunking can be pretty expensive, and it's often not done well. It's a common tripping point, especially for new users, but even for pretty advanced users. And so in this case, we can actually push that rechunking all the way down into the from array operations, right? So we can say, hey, look, I actually should have loaded my data in a different way. I should have loaded my data not just with sort of square normal chunks. I should have loaded my data with differently shaped chunks. And this is interesting. It's a challenging problem, right? Because the rechunking here, I've actually got to map this rechunking across this broadcasts ad, right? So we've got 500, 200 on the first array here. And I've actually got to know, like, I've got to rechunk this second array also by 200 because that's the way it's going to broadcast into the top array. So rechunking gets sort of interesting. And there's sort of various ways in which we can push rechunks through blockwise operations, through elementwise operations, through transposes, through slicing. And that's sort of where the interesting challenge is in the sort of high-level query optimization for array computing. And a final example, just like all of this works within Xarray 2, or it used to. Yeah, it does work, I promise. But
that thing is X. I don't know if you want that to be like C.
Yeah, very good. Thank you, James. Yeah, so Xarray actually doesn't require a whole lot of Dask array, and so we actually already satisfy the like constraints that Xarray requires. Xarray is a major user of Dask array. All this stuff will percolate through. Obviously, we're not done yet. Like simple things like there's no array, there's no HTML representation here. There's a lot of things that are broken. You shouldn't use this today. You'll get wrong results. There's lots of to-dos in the code. But I think most of the hard problems are solved. And again, I think most of the value we're going to see is pushing things like rechunking and slicing through a lot of operations and making some moderately intelligent decisions for users. I think it's going to be the biggest win. That'll help, I think, a lot with making Dask Array and Xarray and other projects a lot more robust in their performance. And I think broaden out the accessibility, especially as we start to get sort of less and less sophisticated users. Anyway, that's what we got.
Awesome. Thanks, Matt. What questions do folks have?
I
Got a
have a
question. Go on, Charles.
Oh, yeah. So just still being relatively new to understanding the way Dask is set up, is there anything, this is to understand specific to Dask Array, or does it work or is there roadmap to eventually apply it to the other Dask APIs?
So Data Frame was the first project that we applied this treatment to, and that is being done now. And as I mentioned at the beginning, like we're actually pretty much at parity now. So we're going to make that switch over the next month or two. Array is the like other major case where this will have a large effect. That's not done yet. That'll eventually happen. My guess is like sometime Q2, Q3 of this year. I can imagine doing this for Bag. Bag is pretty simple. It's not that big of a deal. And there's probably not a whole lot for us to actually like, there's not a whole lot of optimization to do there. And then futures, it doesn't make sense at all. Futures and delayed are way too low level. This wouldn't make sense.
Cool.
Did that answer your question, Charles?
Yeah, it does. Thank you.
Yeah. But people should be like very excited about the data frame stuff that's going to land soon. Yeah, that's fun. Great. There's nothing else.
Any other questions? Yeah, okay. If not, then thanks again, Matt. Sarah, 1 billion row challenge. Floor is yours.
Great. Thanks, James. I will share my screen. Cool. Can everyone see like this blog post I'm sharing at the moment? Cool.
Looks good.
So a little bit of context. Earlier this month, this 1 billion row challenge was launched, which is primarily for Java implementations. And the basic idea is that you take a text file and it's got rows for different weather stations, and you do like a group by with various aggregations on that, calculating the min, mean, and max. And all these people were submitting lots of different ways of doing it as fast as they could in Java. And then there were also some cool submissions for Python. So this is the discussion here that you can kind of follow along with. This is the Python one that sort of kicked it all off. And they did a few different implementations in Polars, in DuckDB, and then some other versions in, like using like PyPy and all sorts of different ways in Python to make this go as fast as possible, which is kind of fun. So we thought we would try it for Dask and see how Dask did. So it's like, this is mostly for fun, I guess, is the context around this. But it was cool. So this is the submission that we did for Dask. And I wanted to walk through a little bit of like where this started. So, and like some of the different ways that I tried it first and what happened. So I've got a Dask client already. So this cell is what the code looks like for Dask. This is just reading in this file using like read CSV. And the first time I did it, I just did it using Dask data frame. Oops, I should probably import it first. So this is going to take about a little less than a minute. And this is, I'll like go down to this and then go back to it. But going back to what Matt has already mentioned, then I switched to using Dask expressions, which is the library that soon will be, soon this will all look like Dask data frame. There won't be like a separate importing here. But this was the first thing I tried, and it's like a little slow. This is just on my laptop, so I'm on an M1 Mac. I've got like 4 workers here, and it should be done in just a little bit longer. But it feels like long enough where it wasn't super exciting. You're sort of like, okay, this isn't that fast. And I'm actually maybe just gonna stop. Okay, so that takes about a minute. yeah.
I'll briefly jump in
Yeah,
and
did
say,
you want to
like,
jump
actually,
in?
like having the slowness in demos, like the pain that everyone experiences, is actually kind of nice sometimes. Like, oh, wasn't that painful? Let's reduce that pain. Was everyone feeling awkward? Yes, we're all feeling awkward.
Thanks for saying that out loud. Yeah, it feels pretty uncomfortable. So then the next thing I did was adding in like the engine equals pyro uh, and like dtype backend equals pyro. So that's now we're going to be using pyro strings with Dask data frame, and that helps quite a lot. So this is still just, using what we have in Dask data frame already. It's still going to be kind of slow though, so it should take like I think this one was maybe 40 seconds instead of about a minute. Um, but adding in like those options for Pyro definitely helped quite a bit. Um, okay, so that's like 36 seconds, which is a lot better. And then I tried it with Dask expressions, and I want to give a little bit of a shout out to Patrick for this part. So I tried it with Dask expressions first, actually, but some of these keyword arguments hadn't been implemented yet for read CSV and Dask expressions. And this was like, I don't know, a week ago. And Patrick was like, oh, give me like a day and I can help out with that. We can see if we can add those in. So thanks, Patrick. And then with Dask expressions, Patrick can definitely say more about this, but you can kind of immediately see, so it's now consolidated some of those tasks even. So with just Dask data frame, I forget exactly which tasks it had, but it had like a different task there specifically for sorting, which is now happening smarter with Dask expressions. And there's still mostly IO time. Like a lot of this is measuring how fast Dask is reading in a CSV. So that time it took slightly longer, but usually it takes slightly less time than the Dask data frame version. So it like, in the grand scheme of things, this is probably not the most important, interesting way to show off how fast Dask is or isn't. And we wrote a little bit more on that in the blog post. But it's still really cool to see how fast Dask is running, like just on my laptop, doing this sort of simple thing. I think Jacob too, you mentioned that you had run something using QDF, right, on a GPU. I saw that like this morning before signing on.
Yeah, I've been playing around with this since I saw your blog post. Actually, this is like quite neat to play with. But yeah, running with GPUs. I've got two GPUs in my workstation, and I just ran it. It took just under 5 seconds. We also tried it on just like a gaming GPU on like a normal gaming PC, and that took 18 seconds, which is still a pretty decent gain. And that's just using the like with Dask config set data frame backend QDF, and the rest of the code's the same.
Cool.
I also rewrote the data generation this morning because I tried to do 10 billion rows to see what scaling was like, and their Java code doesn't like 10 billion because the integer overflows, and also it's really slow. It takes like 15 seconds to generate the 1 billion rows.
It's so slow to generate. Yeah,
so I rewrote that with like GPU code as well. So now you can generate 1 billion rows in like 25 seconds, and then 10 billion takes like a couple of minutes.
Oh, nice. Did you share it?
I will in a minute. I'm going to push it into the Rappers docs in a minute because it's like a neat example to share. But yeah, I'll share that as well.
Does this mean we're
someone
doing
in the yeah, exactly.
Say that again, Matt?
Sorry, does this mean that we're doing the 1 trillion row challenge soon?
I mean that's 10 terabytes of data, which isn't like insane.
Correct. It is not insane.
So yeah, I want to play with that next. I was going to go for 100 billion next. I was probably going to switch from my workstation to maybe a server with more GPUs in there.
Yeah, that'd be awesome. I like hit that same block. I just didn't rewrite it. But I was like, oh, I'm going to try to scale this up. And it was like, no, you won't. This file will not create for you. So that'd be cool.
I think it'd be fun.
I wonder how many entries there would be in the 1 trillion row challenge also.
I mean, all the projects could do it. This is like the TPCH work. Like we ran TPCH on Polars, DuckDB, Spark, Dask, and like the data sets there got into the the trillions. It's not maybe I guess the sorting bit is hard, but like they can all do it. It'd be slow. You also did this with Spark, right, Sarah? Is that right?
Oh yeah. Sorry, I'm not fully caffeinated yet. Yeah, I did do it with Spark. Spark was a lot slower. Yeah, so this should go. And I don't know Spark as well, so this is like here I think I'm like trying to tell Spark ahead of time, like, hey, expect some strings here and some floats for that column, and then I get some of these warning messages. But then for Spark, it actually takes about 2 minutes, which, we can chat about some other things in the meantime while we wait for this to come up. But yeah, I think Matt, you were commenting that Spark isn't known for like optimizing reading in a CSV, like actual querying from a table would be pretty quick, but loading into memory is
Yeah, I suspect
not
that
its strong
probably
point.
this is this like testing a project's CSV parsing capabilities. That's my guess is where the bottleneck is. Maybe the sorting. I'm actually kind of curious about the Pyro. Like, seems like the biggest benefit that we got here was the Pyro
Yeah.
CSV reader. And like, should we think about switching to that sometimes? Or like maybe we try and then back off to pandas? I'm curious if pandas people are around and have thoughts on that switch. Mostly I'm
The
actually
arrow
scrolling.
reader is broken in various the arrow reader is broken in various ways. We would have to try and see how it goes.
Is it broken for like 2% of users though, or for like 20% of users?
I would say for pandas it's more like 30 to 40%. I don't know how this fits for Dask.
Okay.
How much of it is the reader? And I think you changed the reader and the D types right at the same time there. Does the D types help for the actual
The types help more
compute
than the
operation?
reader.
Yeah, okay.
Because the path from object to string, string to object and then back to string is what takes up most of the runtime in Dask.
Yeah, makes sense. Makes sense.
So you're round tripping basically if you don't change the reader backend.
Yeah, and Sarah, something else I wanted to mention is you were comparing Dask data frame and Dask expressions, and there's not a big difference. But and maybe for not for this particular simple case where you're just reading and doing a group by, but in general, Dask expressions also makes it a little bit easier on the user. Like if you didn't specify, hey, I want to read these columns and everything like that, Dask expressions should be able to figure out I don't need to read all of the columns, whereas Dask data frame less so is good at that. Like if you're immediately selecting the columns after the read, it can figure it out sort of through like manual, like we've hard coded it in the optimization, but Dask Express is just generally better at that.
Yeah, that's a good point, Rick. Someone had shared, I think, some version of benchmarks they had done maybe like 2 years ago and linked to an ongoing discussion of like, I'm not sure who on this call opened up the original issue, but like, hey, maybe we should have an expression layer for Dask data frame. Wouldn't that be cool? And it was like they were pointing to exactly what you just said, Rick. Like I kind of had to add in this workaround where I'm adding in all the columns that I know that I want ahead of time, which a naive user, or like even in some scenarios, you don't exactly know that ahead of time. But it is also kind of cool to see all the work in Dask expressions coming together after seeing that original issue from a couple of years ago.
How did Polars and DuckDB do? I assume they beat Dask and Spark.
Yeah, that's a good question. So on my say that again.
Sorry, go ahead.
I was gonna say, so on my machine, Polars was, I think, at the fastest about 20 seconds. And then shortly after that, someone shared a slightly more optimized like Polars implementation, which now is taking, they're saying 11 seconds. Their M1 has more memory than I do on mine. Mine is a 16 gig. The DuckDB one actually crashed when I ran it on mine. So I think I was doing something a little differently, or I needed to make some tweaks because maybe theirs has more memory. I'm not exactly sure. I didn't dig into that super deeply. But yeah, Polars and DuckDB. Polars was like still in the ballpark though, like faster, but not outrageously so when I ran it myself.
Yeah, I see about 30 seconds pretty consistently for Polars on my workstation.
Okay.
I'd be excited to see the 1 trillion
Any
row
other
challenge.
questions?
That would be a fun response. Like the billion row challenge seems to have like been more popular than I would have expected, given the simplicity of it. But it'd be fun to just like do that again, but much bigger.
But it ends at the end of January, right? So maybe February should be trillion row challenge.
Just scale up with every month.
Yeah.
Maybe by December we reach.
We could do a quadrillion rows. That would take some effort, but that's doable. 10 petabytes.
That's a petabyte. Yeah, 10 petabytes. That's quite a lot.
I mean, like I think Sarah, you did a 1/4 petabyte on a different workflow, like an X-ray thing. I'm sure something would break it to fix it, but we're talking about like a order of magnitude greater than we normally do, not many orders of magnitude greater. Sure, it'd be painful, but like it's doable.
Maybe with Parquet. CSV is getting painful when it gets that big.
I mean,
You
CSV
can do it,
scales.
I know.
It scales.
It
It's like not there's no nonlinearity in CSV, just number of files.
Yeah, that's fair.
Any other questions? For what it's worth, I put in the chat a link to the blog post that Sarah wrote that kept getting referenced earlier in the discussion. So if folks are interested, they can go click that.
Thanks, James.
Thank you. Any other questions we have for Sarah or any of our speakers today? I have one small one that I've been holding because it is really, it's very tiny. Charles, I noticed when you were going through your notebook, you basically did like cat, but with Python syntax highlighting. What tool was that? Because I do that all the time. It'd be nice to like have some syntax highlighting.
Yeah, I only learned that for the purposes of this meeting. Let me find that and tell you.
Cool.
I think it was
Pigmentize, I think. And here I'll put here's the notebook so you can see. I forgot to put that in the chat. Here's the notebook that I just presented. Absolutely. And it is Pigments is the Python package, and then Pigmentize is Pigmentize-G, which I think stands for guess, maybe, because it can do it's not just syntax highlighting for Python. You can do like YAML or whatever, any language. So yeah, thanks for noticing that.
Jacob's
James.
also, for sure, of course. Thank you for sharing. Jacob is also recommending, for those watching at a later time, Jacob in the chat is recommending bat, I'm assuming, instead of cat.
Yeah, bat is like better cat, but it's
nice.
It's really good. And it does all syntax highlighting. You can like cat or bat like a JSON file or a CSV or whatever, and it like highlights it all really nicely, and
Oh, cool.
it's great.
Cool. I see Nat is liking bat as well. Nat, you might consider if you ever wanted to rewrite bat or make a better bat, it could be new bat, which could be Nat, if you're wondering. So, unless there are any other questions with that, I think we're leaving on a high note.
Thanks, James.
All right, cool. Thanks, everyone. Thanks again to all the presenters, and see you next month. Have a good one.